Now is the time to discuss area between curves where we will be using horizontal rectangle and then setting up a dy integral. So in these three pictures, are you able to determine the top curve and the bottom curve? The answer is no, you are not able to do so. So when you cannot use the top curve minus the bottom curve, then you will have to consider using the right curve minus the left curve. So if you look at these problems, so most of the functions, they are x in terms of y, right? So let's say number one, x is equals to y squared minus 1, x equals to 1 minus y squared. Number two, you have x equals to 2y squared. So if you are if you are trying to use your graphing calculator, TI-83, 84 to graph this function, I don't think you can just press the y equal and then enter this function. I don't know how to use a TI graphing calculator to graph an x is to graph this kind of function. If you know how to do it, feel free to leave a comment below and provide some directions so other viewers can learn from you. But there is a free app. I highly recommend you to go download it and try it out. That is called Decimals. This video is not sponsored by them, so that is completely free. You can do this on your computer, your phone, or your iPad. It is available in Android and iOS, completely free. Just download it. On the left hand side, it is very easy to use. So let's say you want to graph the first function, x equals to y squared. Just type it, x equals to y squared minus 1. Just type it out, and then they will give you a graph, and then you move on to the next line, type 1 minus x equals to 1 minus y squared. They will give you they will graph the function in another color. So if you look at the picture, you can zoom in and zoom out, and if you point at the intersection, you can easily find the intersection. But when you do your works in class, especially on exam, you will have to show your work to find the intersections. All right. So let's take a look at the first one. So the first problems we have is x equals to, so we have two parabola, one facing the right side, one facing the left side, right? So where is my area? The area is bounded right here. And then how do you know which one is the right, which one is the left? Easy. You draw a rectangle. In fact, you don't even need a rectangle. When I was learning this, I don't even draw a rectangle. I draw this, and then shoot a horizontal line to the left, and then another line right here. So which one is touching the right, which one is touching the left? The point that is touching the right is 1 minus y squared, right? The point that is touching the left is y squared minus 1. So you can easily tell that the right curve is x equals to 1 minus y squared, and then the left curve is x equals to y squared minus 1. All right, and then y goes from where to where? Y goes from here to here. So what is this y and what is that y? Solve an equation for me. So you have 1 minus y squared equals to y squared minus 1. Keep the y squared positive. Let's move everything to the right. So y squared plus y squared, negative 1 minus 1. And then you factor out 2. Y squared minus 1. So that gives you 0 equals to 2. Y plus 1. Y minus 1. Okay, so y is equals to 1 and negative 1. So we have a negative 1 and then we have a 1. So that means in this integral, we have y goes from negative 1 to positive 1. So the setup is finished. We have all the necessary ingredient right in front of me. Let's construct the integral. So the area is equals to integral y goes from negative 1 to y goes from 1. If you are doing homework online, you don't need to type the y equal, because I don't think the system can read the y equal. Just type negative 1 and 1. And then right minus left. And then the integral is dy. So the right curve is 1 minus y squared. And then the left curve is y squared minus 1. And then this is only set up but do not evaluate. You do have to combine the line terms using simple power rule to integrate, and then using fundamental theorem of calculus to evaluate the integral. I will just stop at this point. So let me explain this one more time. Why do we have to use the right minus left? Why? So here is the reason. You have rectangle, right? And then the point on left curve and right curve. So this is 1 minus y squared. This is y squared minus 1. How long is this rectangle? How long? So if you go back to the picture, let me use another color. This corresponds to an x value. The point on the left corresponds to another x value, right? So let's say that corresponds to x2, that corresponds to x1. How long is this? You have to use the mark on the right to subtract the mark on the left to get the length of the rectangle. That's why you use right minus left. A bigger x value, subtract a smaller x value to get the length, and the length is positive. That's why it's right minus left. That's how they came up with such idea. Okay, so number 1 is done. Let's take a look at number 2. So number 2, we have x equals to 2y squared and 4 plus y squared, right? So a green function and a blue function. Of course, you are not able to determine which one is top, which one is bottom. So what do we have here? We have 2 intersections. So let's switch to another color. We have 2 intersections, one here and then one in here that corresponds to a y value. Each corresponds to a y value. Let's figure them out. So we have a 2y squared equals to 4 plus y squared, and then put everything on the left. 2y squared minus y, 2 minus 1 is 1, and then minus 4 equals to 0. So you have y plus 2 times y minus 2 equals to 0. So y equals to 2 and y equals to negative 2. So we have negative 2 and 2. So we know that the integral is from y equals to negative 2 to y equals to 2. And then you determine the left and right. This is very obvious. So let's say you pick this point and then you pick this point using the midpoint rule. So you do this, right? This is the delta y. Then you do that. So this is your rectangle, left side and right side. And then the left side is touching what? Is touching the green parabola, which is x equals to 2y squared. And the right side is touching the blue parabola, which is 4 plus y squared. So we just have all the ingredients. We do from negative 2 to 2, and then right curve minus left curve, and then dy. So that is 4 plus y squared minus 2y squared dy. All right. So that is the end of number 2. And then we have another one. So that is number 3. Let's move on to number 3. So number 3, I know we are running out of space. That's why I copy and paste the problem over here. This is a special case. Do you know why? Let's take a look. We have x equals to y to the 4th and y equals to 0, which is the x-axis. Oh, by the way, now is a good time to put this in your brain. Y equals to 0 is the x-axis. X equals to 0 is the y-axis. Look at the graph. This is true, right? Can you put this inside your brain? Because we need this for the next lesson, the next topic, volume. Okay, we have x equals to y to the 4th and y equals to 2 minus x. And then one thing that you are going to ask me immediately is, hey, y equals to the square root of 2 minus x. Look at your green function. That is a mistake. That is not what a square root function looks like. Okay, so is that really a mistake? So let's hold on to that. Let's take a look. We have y equals to 0, which is the x-axis, and y greater than or equal to 0. That means we want everything above the x-axis. I want the region above the x-axis. All right, so let me explain why the graph doesn't look like a square root function. Let's match the color code. So let's do the works right here. So this one, we have x equals to y to the fourth. That is a sideways parabola. But you have y equals to that. When you set up a dy integral, I am not able to have two different variables in one dy integral. Either they are all y or they are all x. If they are all x, then that is a dx. If they are all y, then that will be a dy. Okay, this one I want a dy. Okay, then that means we have to rewrite this function. First, we square both sides. So y squared is equals to 2 minus x. And then we have x equals to 2 minus y squared. Then this becomes a parabola. Sideways parabola. So sideways parabola facing this side, because this is a minus y squared. Plus is facing the right, minus the mouth is facing the left. And that's how I got this. Okay, and then take a look at the green circle above the x-axis. So which region are we looking for? We are looking for, above the x-axis, we are looking for this region. So that is the region that we are looking for. And then looking at this picture, we are not able to determine the top curve and bottom curve. As a result, we have to use the left curve and the right curve. Let's pick another color. I hope that the color is not too overwhelming. So we have to do this, a point, and then we connect them. So which one is touching the right curve? The right curve is the green curve, right? That is x equals to 2 minus y squared. And then the left curve is the y curve, x equals to y to the fourth. So far so good. This goes from y to where, because we are using a dy integral, right? So that means we must have y equal and y equal. So that gives me two intersection points that we have to work it out right now, this intersection and that intersection. So to find out the intersection, we have to set them equal. So we have y to the fourth equals to 2 minus y squared. And then we have y to the fourth plus y squared minus 2 equals to 0. So this is y squared plus 2 times y squared minus 1 equals to 0. So y squared plus 2 equals to 0. Y squared minus 1, which is y plus 1, y minus 1 equals to 0. This one has no solution. You square a number, you add 2 to it, you will never get a 0. So this one we have y equals to -1 and past 1, right? So we have -1 and past 1. So that means y goes from -1 to past 1. Look at all the scratch work we did. I didn't jump straight to the integral. I started on the graph, and then I work everything out, and then use all these ingredients to build my integral. So the area is integral from -1 to 1. Of course, they are y, okay? I know you want me to show everything, but when you do your homework online, don't type the y equal, because I don't think the system can read that unless they ask you to input this. Right minus left. Right is 2 minus y squared. Left is y to the fourth, and then dy. So this one you can use simple power rule to integrate, and then plug in the -1, subtract them by fundamental theorem of calculus to get the integral. So this is the integral to find the area, and that is the end of this video. So don't forget to graph x equals to some y. This type of function, use the free app Decimal to do the graph. I don't know how to use a TI-84 or ADB to do the graphs. If you know how to do it, feel free to leave a comment below so other people can learn from you. All right, I appreciate your help. Don't forget, like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your support. See you all in the next lesson. Signing out for now.